The need for ever faster and more flexible material handling processes is making tough demands on material handling equipment. As the complexity of these systems increases, so do the safety requirements. Fault-free travel requires precise interaction between the crane and its runway. Deformation of the rails and worn travel wheels are early signs of impending problems. Just as the wear on car tires can be seen relatively easily and the results felt through the steering wheel, the wheels of a crane are also subject to wear. Damage to the crane rails will increase with breaks and deformations appearing, which leads to one-sided wear on the wheel flanges. With car tires, tracking problems manifest themselves as one-sided wear on the profile. With crane rails, it is the rail heads that bear the brunt. Just as a flat tire will cause damage to the rim, crane wheels running askew will damage the wheel flanges. If tolerances for wheels and crane runways are exceeded, the travel characteristics will be adversely affected. The availability of the installation is reduced and the risk to both the machine and its operators increases. Demag Crane's laser measuring system quickly and accurately assesses the condition of crane runways and ground rails. Corrections can be made without delay and follow-on costs avoided. The LMS laser measuring system consists of a stationary alignment laser, a remote-controlled measuring carriage, a notebook PC, and radio modem. Even the tiniest deviations are detected with the highest accuracy, and serious damage is virtually ruled out. Thanks to rapid targeted response, the lifetime of the installation is considerably increased. Measurement using the LMS is far quicker than conventional measuring methods. Operation of the installation is only interrupted for a short time, which means lower costs and a higher degree of safety. Safety measures such as barriers and warning signs are not required. There is no need to clear and prepare production and storage facilities. It is not necessary for crane runways to be accessible along their entire length. The system works equally well in dusty and dark environments. Since each measurement is performed several times and a statistical average is taken, the measured values are remarkably accurate. Measuring data is displayed immediately on screen and analyzed by experienced Demag specialists. If the crane geometry is out of true, the poor travel characteristics of the crane will become worse. The result will be unscheduled production downtime and higher repair costs. Irregular running characteristics and unusual noises, combined with heavy wear on the wheels, guide rollers, and rails, are typical symptoms. Ultimately, the entire production process is put at great risk. Let's stay with the car as an example. If tyres wear unevenly, the axle alignment needs checking in the garage. With cranes, it is a similar story. Here, Demag Crane's surveying service provides help on site. To do this, we switch off the crane and raise it using hydraulic jacks. This allows the wheels to be freely rotated. The jigs and measuring instruments are mounted on the crane rails and the measuring arms fitted to the travel wheel axles in a similar way to a car. Once the measuring shafts have been set up, the exact wheel position is inspected and analyzed. The results are compared with current standards and the manufacturer's specifications. The cause of any wheel wear and end carriage misalignment is accurately identified and eliminated by a specially developed Demag Cranes process. The repair begins with dismantling the crane and a close inspection of the girder length. To ensure the connecting plates are milled true, a mobile jig is attached to one end. At the other end of the girder, a target marker with a precise scale is positioned for aligning the milling machine. Now the position of the jig can be visually determined and precisely aligned using adjusting screws. Thanks to the precise alignment, it is possible to mill the deformed connecting plates extremely accurately. All the connecting points are machined one after the other. Visual alignment and the milling process are then repeated at the opposite end of the girder. In this way, the geometry of the crane girder can be reproduced within the specified tolerances to 1/10 of a millimeter. Once the end carriages have been refitted, the crane can be returned to the crane runway. The restored crane geometry is documented and handed over to the customer with the crane. The subsequent test drive shows how effective the professional repair was. We measure our success in terms of customer satisfaction.